In this lesson, we're going to learn how to solve radical and rational exponent equations. So I want to remind you of something you learned in a previous lesson, that when you're taking an odd root, like the fifth root of 32, there's one answer. The odd root of a negative value also has one answer, and again, one answer when we take like the fifth root of 0. It's even roots you got to watch out for. You can take the even root of a positive value, you're going to get two answers. But if you're taking the even root of a negative, there's not going to be a real solution. And if you're taking the even root of 0, well, there's just going to be one answer. So this is really the one that causes some trouble. Odd roots, easy to watch out for. There's only going to be one answer. So let's illustrate it with these three examples from your notes. So we have done solving exponential equations with like quadratics, and I think we even looked at some cubic functions this year, but let's do a fourth power. So I want to begin by trying to isolate that x to the fourth, so I'm going to divide both sides by 4 to begin, which gives me x to the fourth is equal to 32. Now, the inverse of raising to the fourth power would be the fourth root. So I'm going to take the fourth root of both sides. When I do, I'm taking the even root of a positive value. I've got to remember that there are two answers here. And what I'm going to do is I'm going to actually break down the fourth root of 32. If you type it in your calculator, you see it's like 2.37. So this would be 16 times 2, 8 times 2, 4 times 2, and that's 2 times 2. So I need a group of 4. I have 4 2s, so it's going to come out as 1, 2 times the fourth root of, I've got 1 2 left over inside. So these are my two answers, positive 2 times the fourth root of 2 and negative 2 times the fourth root of 2. All right, let's look at a power of 5, x to the fifth. So I'm going to begin by getting rid of this 1/2 by multiplying both sides by 2, by the reciprocal. You could also divide by 1/2, but that's equivalent to multiplying by 2. That gives me x to the fifth is equal to 1024. Now I'm going to take the fifth root, the inverse, and the fifth root of 1024 is 4 when you type that in your calculator. So x is equal to 4. Notice there's only one answer here because I'm taking the odd root of something. This one is just a little different because now I have the exponent on the outside of that binomial. So I'm going to begin by taking the cube root of both sides. When I do that, these undo each other, leaving me with just x minus 2, and the cube root of negative 64 would be negative 4. I can take the cube root of a negative value. Now I'm going to finish this by adding 2 to both sides, and I get x is equal to negative 2. Now let's kick it up a bit. All right, so we've taken something that we already know how to do, and now we have radicals in our equation. So how are we going to solve this? Well, our goal is going to be to try to isolate the radical first. Okay, so when I say isolate the radical, I mean we're trying to isolate this cube root portion. So I need to begin by getting rid of this 2 out front, so I'm going to divide both sides by 2, which would produce the cube root of x minus 3 is equal to 2. Now, to get rid of this cube root, I'm going to do the inverse, which means I cube both sides. That produces the radicand of x minus 3 is equal to 8. Lastly, add 3 to both sides, and I get x equals 11 for an answer. One last thing I need to do is check for something called an extraneous solution, which you may think it's a pain, and I get it, kids usually do, but what that means you need to do is plug in your answer of 11 and make sure that your left side is equal to the right side. So 11 minus 3 is 8, cube root of 8 is 2, and 2 times 2 is 4, so it satisfies the original, okay? If it wouldn't, this particular equation would have no solution. All right, let's try 5. So 5 is a little different. This time I have variables on both sides, and I have a square root. So what am I going to do? Well, I've isolated my radicals, so I'm going to square both sides. And when I do, I get just 7x plus 15 on the right. But on the left, what I actually have is x plus 1 times x plus 1. So I've got to multiply my binomial together, which gives me x squared plus 1x plus 1x would be an inner term of 2x plus 1. Okay, you have 4 multiplications to get this trinomial. If I lost you a little bit, pause the video and multiply it out so you see it. Now I'm going to get, I notice I have a quadratic. I'm going to get this in standard form by subtracting 7x from each side, and I'll subtract 15 from each side. Just going to give me 0 on the right, and x squared minus 5x minus 14 on the left. Now it's quadratic, so I'm going to try to factor this. Pause the video and do tic-tac-toe if you need to. I know it factors into x minus 7 and x plus 2. Apply the zero product property, which means take each of them and set them equal to 0. Those are my factors, so my corresponding zeros would be x equals 7 or x equals negative 2. Now, I definitely need to check this one. So I'm going to check my first answer first of 7, which would mean 7 plus 1. Does that equal the square root of 7 times 7 plus 15? I would get 8 on the right, or on the left. On the right I'd have, let's see, 49 plus 15 would be 64, and the square root of 64 is 8. Okay, so that one works. Then I'm going to try negative 2. So negative 2 plus 1. Well, that's going to be negative 1. Does that equal the square root of 7 times negative 2 plus 15? 7 times negative 2 is negative 14, plus 15 would be 1, and the square root of 1 is 1. Negative 1 does not equal 1, so this one is extraneous. So I'm going to cross this one out, and my only answer here would be x equals 7. It's your turn to practice. Pause the video, hit play when you're ready to check your answer. So hopefully you see that your radical is isolated, so you're going to begin by cubing both sides. The inverse, which produces 2x plus 7, is equal to 27. And now I'm going to solve by subtracting 7 from both sides, which gives me 2x equals 20, and then x equals 10. Check your answer, and when you do, the cube root is 27. Does that equal 3? And it does, so this one is satisfied.